Hey there, party people. You're listening to the Scriptome podcast. It's Thursday night, January 22nd, and I walked into MIT's Stata Center for what turned out to be one of the most significant product launches I've witnessed in the AI biotech space. Here's what made me drop everything to be there. This isn't just another AI tool announcement. This is the team behind Boltz One, the first truly open source model to match AlphaFold 3's accuracy, and they just raised $28 million and signed a strategic partnership with Pfizer. I'm Stu Angus, founder of Scriptome.ai, and tonight I want to share what I saw, why it matters, and what this means for small biotechnology companies trying to compete in an AI-first world. So, who is Boltz? Let me give you some context first, because the Boltz story is wild. 3 researchers from MIT's Computer Science and Artificial Intelligence Lab, Gabriele Corso, Jeremy Wohlwend, and Saro Passaro, they're all working in Regina Barzolet's lab. And if that name sounds familiar, it should. Barzolet's lab is basically a hit factory for AI and healthcare breakthroughs. These 3 decided to tackle one of the biggest frustrations in computational drug discovery. AlphaFold 3 is incredible, but it's not fully open source. You can't use it commercially without restrictions. And if you want to actually train your own models or modify the code, forget about it. So in just 4 months, they built Boltz One. Not a close approximation, not almost as good. They matched AlphaFold 3's accuracy across diverse benchmarks. And they released everything. The training code, the inference code, the model weights, the datasets, all under an MIT open license. That was November 2024. Fast forward to today, just 14 months later, and they've already released Boltz 1X for better structural validity, Boltz 2 that predicts binding affinity at 1,000 times the speed of traditional methods, Boltz Gen for generative protein design, and now, Boltz Lab, a full production platform. Oh, and they've also spun out a company structured as a public benefit corporation, raised $28 million from Andreessen Horowitz, Amplify Partners, and Zeta Venture Partners, and signed a multi-year collaboration with Pfizer. The adoption numbers, over 100,000 scientists. Every single top 20 pharma company. Thousands of biotech startups. This is not a science project anymore. This is infrastructure. So let's talk about what they actually demonstrated tonight, because this is where it gets really interesting. The Boltz team walked us through the Boltz Lab platform with a live demo. And I've seen a lot of computational chemistry software in my career. This felt different. They started with small molecule design. You create what they call an experiment. Basically, you're testing a hypothesis. You can run a virtual screen, either generative against predefined molecular spaces or against fixed size libraries. Here's the first thing that jumped out at me. The platform advises you. It'll tell you to run larger screens for better molecular discovery. It has built-in filters like Rule of 5 compliance to ensure synthesizability. This isn't just giving you predictions and wishing you luck, it's guiding you toward better experimental design. Then you run your screen and you get your results. You can analyze structures based on affinity probability, structural confidence, all the properties you'd expect. But here's where it gets clever. They've built collaborative triaging directly into the platform. Multiple medicinal chemists can review the same results, upvote or downvote molecules, and build consensus. They're explicitly keeping humans in the loop. This isn't replace your chemists with AI. This is give your chemists superpowers. And you can iterate, start with an existing molecule, edit it, see what happens to the predictions. Run sequential screens for different targets to check for selectivity. Evaluate multiple properties simultaneously. This is production level workflow thinking. Then they showed protein design. This is where they really flexed. You can do binary specification, similar to Rosetta, for those of you familiar with that tool, but much faster. Want to redesign specific regions of a protein, like antibody CDRs? You can. Want to add custom constraints, like excluding certain amino acids? You can do that too. The example they showed was excluding cysteines in CDR regions to maintain control over the design. You're not just generating sequences blindly, you're defining the rules, and the AI operates within those constraints. Peptide design, same thing. Define length parameters, exclude certain amino acids, work from existing frameworks, or upload your own PDB files. And all of this uses the same triaging interface, same collaborative workflow. Now, the developer experience. This is where I really perked up. They have a sandbox interface for single-shot predictions, quick tests, familiar interface, similar to other platforms many of us have used, but they've also released a command line API, and they're releasing an SDK for Python and TypeScript soon. For my clients building internal computational pipelines, this is huge. API access means you can integrate Boltz into your existing workflows. You're not forced into someone else's web interface. You can script it, automate it, embed it in your own tools. And here's the kicker. They're offering free credits to new users. The platform is at boltz.bio, boltz.bio. They're accepting new users daily. Why this all matters? All right, let me connect the dots here. Because if you're running a small biotech, or you're a scientist at a mid-sized company trying to adopt AI tools, this announcement is directly relevant to you. For small biotechs, first, the cost barrier just collapsed. You don't need a $10 million compute budget to access AlphaFold 3-level predictions anymore. You get free credits to start, and even when you scale up, you're paying for infrastructure, not for model access. Second, the workflow is designed for small teams. Collaborative triaging, human-in-the-loop design, API access for custom integration. This is an enterprise software that requires 6 months of implementation consulting. This is sign up, get credits, start running experiments. Third, it's fast, 30 to 60 seconds for predictions that used to take hours or days. That's not incremental improvement. That's a phase change in iteration speed, the business model. Now let's talk about why this company might actually succeed where so many other AI for drug discovery companies have flamed out. The Boltz team raised $28 million from top-tier VCs, Andreessen Horowitz, Amplify, Zeta. These are not people who bet on science projects. They bet on platforms with massive TAM, total addressable market. And Pfizer isn't just a customer, they're a partner. Boltz is using Pfizer's proprietary data to train custom, exclusive models for them. Structure prediction, small molecule affinity, biologics design. That's not a pilot project. That's a strategic integration. But here's the genius move. They structured as a public benefit corporation. They're committed to open science. The base models stay open source. The community keeps contributing. They build goodwill and adoption. And they monetize through the platform, the infrastructure, the workflows, the enterprise features. It's the Red Hat model. Give away the software, sell the service layer. One more thing. This is the third or fourth major AI for biology breakthrough to come out of Regina Barzolet's lab in the past few years. There's something happening at MIT, specifically at CSAIL, where the culture of open source collaboration is translating directly into commercial success. The Boltz team made the point tonight that they come from an environment where patenting is rare and open releases are the norm. That's not typical in biotech. Most companies spin out of pharma or wet lab groups where the default is to patent everything and keep it closed. Boltz is doing the opposite, and it's working. Walking out of the Stata Center tonight, I kept thinking about conversations I've had over the past year with founders and CSOs at small biotech companies in Massachusetts. The question always comes up, when is AI actually going to help us? When do we get access to tools that aren't just vaporware? The answer is right now. Boltz Lab is live, it's production ready, it's free to start, and it's designed by people who understand both the science and the workflow. If you're curious, go to boltz.bio, that's boltz.bio, and request access, try the free credits, see if it fits your workflow. And if you want to talk about how tools like this fit into your organization's AI strategy, reach out to me. That's literally what I do at Scriptome.ai. Help small biotechs figure out which AI tools are real and which ones are hype. This one is real. I'm Stu Angus. Thanks for listening to the Scriptome podcast.